Good morning, student. Today's topic is Tyndall Effect. What do you mean by Tyndall Effect? Tyndall Effect means the scattering of light by the colloidal particles. It is observed when a beam of light is passed through a colloidal solution, then the colloid particles scatter the beam of light. Its path becomes visible in the solution. The colloidal particles can be seen with a zigzag path. Zigzag path means Brownian moment. The particles present in the colloidal solution that have big size to enter the light present in the beam. These rays as well as the colloidal particles become easily visible. But this effect is not observed in a true solution because the particles present in a true solution that are too small to scatter the light. What are the observations which shows Tyndall effect? First, when a light enters a room through a small hole due to the scattering of light by the dust and smoke particles. Second, we can see in a dense forest due to the scattering of light by the water droplets in the mist. These tiny droplets particles present in the forest that acts as a colloidal particles which scatter the beam of light as it fall on them. So this shows the Tyndall effect, means the path of light becomes visible. By the help of activity, we can easily see the Tyndall effect. Suppose you take two separate jars. Take ferrous sulfate solution, that is light green in color, and a milk solution diluted with water. Focus a torch on this jar. This is jar number 1 filled with the ferrous sulfate solution. This is jar number 2 filled with milk. Ferrous sulfate solution and milk. Focus a torch on these jars and these are kept in a dark place. The torch light will not be visible in ferrous sulfate solution, this one. But the same can be seen in milk solution. Ferrous sulfate solution is a true solution, so it does not shows any Tyndall effect. But the effect will be noticed in the milk, which is an emulsion. Emulsion means mixture of liquid and liquid or colloidal solution in nature. Means Tyndall effect is observed in milk because it is a colloidal solution, but does not observe in ferrous sulfate solution because it is a true solution. Its particle is very small. This is Tyndall effect. Now, what is the difference between suspension, colloidal solution and true solution? This is the most important question for your exam. Point number 1, particle size. In the case of suspension, particle size is greater than 100 nanometer. In case of colloidal solution, it is 1 nanometer to 100 nanometer. Solution, it is less than 1 nanometer. Second point is filterability. Filterability means ability to filter. Means in the case of suspension, the particles cannot pass through the filter paper. Means it can be easily filter. Solute particles left in the form of residue and the filtrate will separate out. But the colloidal particles can pass through the filter paper. In case of true solution, these particles pass easily through the filter paper, like a sugar solution, easily pass through the filter paper. In case of colloidal, like milk, soft solution, easily pass through the filter paper. Point number 3. Settling of particles means particles are settled down or not. In case of suspension, we easily observe from sand solution, particles are settled down on their own. Particles are settled down only on centrifugation. Centrifugation is a method to separate the particles, colloidal particles. It is just like a washing machine dryer. It rotates like a dryer in a washing machine. But in true solution, particles don't settle. Appearance. Suspension may be opaque or translucent. Colloidal solution is transparent or translucent. True solution is always transparent, like a sugar solution, salt solution, etc. Tyndall effect. What do you mean by Tyndall effect? The scattering of light by the colloidal particles. Suspension shows Tyndall effect because particle size is very large. But colloidal solution also shows Tyndall effect, means its particles scatter the light. But true solution does not show Tyndall effect because its particle is too small. Point number 6. Diffusion of particles. Diffusion means intermixing of particles. In case of suspension, particles don't diffuse. In case of colloidal solution, particles diffuse slowly. But in case of true solution, particles diffuse rapidly. Now next is Brownian moment. Means random motion of particles or zigzag path. Suspensions may show the Brownian moment. Colloidal solution also shows Brownian motion, but true solution may or may not be shown. Nature. Suspension is always heterogeneous in nature, but colloidal solution they may appear to be homogeneous, but actually it is heterogeneous. And true solution, it is always homogeneous, means its composition is uniform throughout the mixture. Now what are the example of suspension? Like the mixture of sand in water, mixture of chalk powder in water, etc. Example of colloidal solution: milk of magnesia, cough syrup, clouds, milk, soft solution, etc. In case of true solution, example seawater, alloys, and alcohol in water, etc. Thank you, students.